Hi everyone, welcome to this new lecture of hydraulic machines. In this lecture, we'll discuss a new concept regarding the force exerted by the jet on the curved plate when the plate is in moving in the direction of jet. So up to now, we have discussed many conditions regarding this curved plate or vertical plate or inclined plate. Uh, Two conditions are there. One is the plate is in moving condition, another one is plate is in stationary condition. So stationary condition already we have discussed previously. So this is the case of moving condition. So here the concept we have taken, you can see here, this is a diagram what I have taken from the book. A plate is there. So here let suppose draw a pipe line, and from this pipeline a nozzle is connected to this one, and from this nozzle the water is coming out. So this is called the jet of water which is coming out from the pipe. So as you can see, this one, let me name it, this is the pipe is there, and this one we can write this is nozzle, and this is the jet of water which is coming out from this pipe. Okay, and this one, as it is named here, this is the moving curved plate. So this plate is a curved shape, but it is not fixed. So after striking the jet of water here, the plate started moving. So initially the jet is moving, the jet of water is moving with a velocity of v, and after striking this plate, the plate started moving with a velocity of u. So there are two velocities are present in this. So let me write some parameters which is required for this derivations. So we need to find out the force exerted by the jet of water on the curved plate when the plate is in moving condition. So this is our motto to identify to in this lecture. So for this, we'll consider some parameters as I told you. First one, you can consider the v equal to the velocity of the jet. So you can write this is velocity of the jet, and this one we can write the unit will be for this, that is velocity meter per second. Similarly, the next one is small u. This is you can see the velocity of the, this is velocity of the plate. So after striking, not jet, this is plate. So after striking, we can see the plate started moving with a velocity of small u. And next one is, we can write this is d, diameter of the jet. This is, we can write this is diameter of the jet. Similarly, we can find diameter of the jet, unit we can write this is meter. And with related to this diameter, we can calculate the area. So this is the cross sectional area of the jet. The unit will be for this will be meter square. And how to find out this one? This one we can calculate. This is pi by 4 d square. Okay, so these are the parameters what we have considered for this. Now again, yeah, now here in this condition we can see what are the conditions can be considered here. Those who is observing this one, they can face some difficulty that what is the concept. For them I'm telling you, here we have taken a jet. Jet is nothing but the jet of water. That means the water is coming out with jet velocity. So this is the concept in the topic of impact of jets. See the topic in the impact of jets, and the impact of jets having the application in turbines. Okay, so to study the turbines, before that we need to understand what is the impact of jets. So the jet of water on plate. So plate is what kind of plate here? We have taken here inclined. This is not inclined, sorry. This is curved plate. Okay, because we have three different types are there. One is vertical, one are inclined, and one is curved. So this one is curved. The plate is curved, and what is its position? This is moving. The position is, it is in moving condition. Okay, and here another one is there where the jet striking, where the jet is striking, because the jet of water can strike at the center of this curved plate, at the one end of the curved plate, at another end when the plate is symmetrical or unsymmetrical. So the condition here is the jet is striking at the center of the plate. So these are the conditions out there. Center of plate. Okay. Now, though we can see we have the velocity of v of impact velocity of jet, and the u is the velocity of the plate. So here we need to consider a term called, this is relative velocity. A term called relative velocity need to be considered here. The concept of relative velocity already we have discussed previously. This is the relative velocity is nothing but the velocity of an object we need to observe from the perspective of another object. That means one object is plate, another object is jet. Okay. So suppose I already given an example for this. One object is moving with a velocity of suppose VA, and another object is moving with a velocity of suppose VB. So VA value is suppose here it is 40 meter per second, and this is VB equal to suppose 20 meter per second. Then here if you calculate the velocity, relative velocity, that means we need to say that the relative velocity of an object, which object we need to consider? This one. So relative velocity for the object VA, okay, from another perspective of another object. That means with comparison of this VB, we can calculate the relative velocity of VA. That means we need to do some comparison between two objects to identify the relative velocity. So here we can write this is VA minus VB. So that means here what we can consider here, this is impact of jet. So jet also moving, we can see the jet of water is moving. Along with that, the plate also started moving after impacting this one. So jet, this plate also started moving with a velocity of small u. So here the relative velocity you can write the relative velocity of, for what we will consider the jet speed. So what I'll write here, the relative velocity of, yeah, here I'll write relative velocity of the jet of water, or we can say with respect to relative velocity of jet of water with respect to plate, or we can say this one simple, that the velocity of which the jet strikes the plate. Okay, so this one we can write, this is nothing but v minus small u. That means this is the v is the velocity of the jet, as I told you. So this is also used to call, this is absolute velocity. This is also called is absolute velocity. So we can say this one also you can write, this is absolute velocity minus velocity of plate in the direction of jet, that need to consider. So this is our relative velocity which you need to consider. Okay, that means the v minus u is nothing but the jet of water at which that jet is striking the plate. Okay, so now we can see if the velocity here it is v minus u we have considered, then obviously after striking this jet to the plate, which velocity will be come out from this fluid, that means which at what velocity the liquid will be come out from this plate. Yeah, now we need to consider another one concept. We need to consider that the plate is smooth. We need to consider the plate is smooth, so that there is no loss of energy will happen in the plate due to the impact of jet. There will be no loss of energy happen in this. So if the plate is smooth, we can say at what velocity the fluid the jet comes, the same velocity the jet will be goes out. That means if the velocity is v minus u, this is nothing but vr, the same vr will be move out from this at the end outlet of this plate. We can say whether the jet come out from here, the same thing at the in this side also we can consider this is the same velocity v minus u. Okay, now so you can see here the jet of this fluid which coming out from this blade or from this plate, that makes an angle of theta with respect to the jet directions. With respect to the jet direction, you can see this is the jet direction, and if you consider this is the jet direction for the fluid which is coming out from here, that is, this makes an angle of theta here. Okay, so this is theta. So now this velocity we need to resolve in two components. Very simple. This velocity we need to resolve in two components because we need to consider to find out this force exerted by the jet of water on a plate. We need to consider only the normal condition force. That means at what jet of water is striking this plate, that should be normal. So we need to resolve this velocity in y direction as well as in x direction. So we can next we can write the component of, next I'll write the component of velocity, component of velocity perpendicular to the direction of, perpendicular to the direction of jet, the direction of jet, that means at y direction. That means, see, the component of velocity, that means as I told you, this velocity will be resolved in two components. One is x component, another one is y component. So this is x component and this is y component. So if you write, now what I written, component of velocity, this velocity component perpendicular to the direction of jet. This is the direction of jet, so which is perpendicular to this one, that means y. So here we can write this is the velocity is nothing but v sine theta. So v is here is v minus u, so this is v minus u sine theta. Similarly, we need to consider the component of velocity. Here again we need to write two velocities are there. Component of velocity we need to consider in the direction of jet. Velocity in the direction of jet, in the direction of jet, that means x direction. At which direction the fluid is flowing, or at which direction the jet is moving, in that direction we need to find out the next component. That means this component of velocity we need to resolve in x direction. So is the x direction means this one. Actually x direction is in this direction the jet is moving, but here if you see the arrow mark of this, the direction of this which is coming out, so that means this will be resolved in this direction, so with an angle of theta, so that is v minus u cos theta. Though this v minus u cos theta is reversed to the x direction, so that's why we need to consider this is negative of, that means minus of v minus u cos theta. This is the two things we need to consider. So this one we can give an equation 1 and this one we can give equation 2. I hope you understand how to resolve the components, a velocity component or a force component also. It is very simple to resolve the components with respect to the some angle. So angle is given here theta, so we can easily resolve this one. Now next target is we need to find out the force. Okay, so before going to calculate the force, let identify one more term, that is mass of water striking the plate. So this is also one part of this. So let's write the mass of water, the mass of water which is striking the plate. So this is nothing but m. So this one we can write the mass of water striking the plate, that is nothing but we can write here, this is m equal to if I write m, okay, this is mass per second, the mass of water per second we need to consider, so that we can write this is mass plate per second we can write. So this is mass per second. So mass per second we can again write this one in place of mass I can write this is rho into v, okay, density into volume by time. So time we can write this is second. So again this volume per second we can write this is rho into q, discharge. So in place of q we can write this is rho a, q place we can write v. So v is nothing but velocity. Now here this q equal to av, we know that. Now this one, what is the velocity here? So velocity is nothing but, here we have considered rho a v minus u, at which velocity the jet strikes the plate, so that is v minus u. So this is the mass of water striking the plate per second. Now we can find out the force exerted by the jet. So this one will find out the force exerted by the jet of water, force exerted by the jet of water on the curved plate, on the curved plate in the direction of jet, in the direction of jet, in the direction of jet in the sense with in the x direction, in the direction of jet. So this one, let me change this color. So here we will get, this is nothing but Fx. Okay, so Fx equal to, we can write this is mass striking per second, mass striking per second, this one, mass striking per second into, this is initial velocity and final velocity. So this is also, I'll write shortcut here. This is initial velocity v1 and this is, I can write v2. Okay, so this one actually it came from this equation. I'll give a arrow mark, I'll write here. This is, we know that as per the Newton's law of second law of motion, we know that F equal to, like the force exerted equal to mass into acceleration. So here again acceleration, we know that acceleration is defined as the change in velocity with respect to change in time. So this is nothing but dv by dt. So this mass by time, we can consider here mass by time, mass per second, and this dv is nothing but change in velocity. Change in velocity is nothing but initial velocity at which the jet strikes the plate, and v2 is nothing but that is final velocity. So this one we can again write this, this is mass per second, and here it is v1 minus v2. So v1 minus v2, why? Because impact of jet or the force exerted by the jet on the plate, that's why we are considering the initial velocity v1. If the force exerted by the plate on the fluid, on the jet, then we need to consider that is v2 minus v1. Okay, so we need to consider in this way. Now again we can write, this is, as you can see, Fx equal to, we can write what is this value, already we have calculated here, you can see. So just put this value here, this is rho a bracket start v minus u, this is mass of water striking per second into that bracket start initial velocity. Initial velocity v1 equal to nothing but initial velocity with which the jet strikes the plate in the direction of jet, in the direction of jet. So this is nothing but v1 equal to this one, yeah, minus of this. Okay, so this is nothing but, okay, this is this is final velocity. Initial velocity is v minus u, normal initial, that means at initial condition what is the velocity. So this is, we can write also this one v1x minus v2x, this also can be written. So this is here, our v1x is here, initial velocity before striking. So yeah, this is v minus u minus this, we can write this is you can write plus, and here we'll get v minus u, which is cos theta, bracket close. Now here we'll do one thing, we'll take a common of this term. So if I take a common of this, this is rho into a, and here if I take common v minus u, see here v minus u, here also v minus u, let's take a common of v minus u, and outside already v minus u is there. So that means this will be v minus whole square, bracket start, already v minus u is already gone from here. So we can write this is 1 plus, here what is the remaining part will be, this is cos theta. So this is our force exerted by the jet of water on the curved plate in the direction of jet. So this is the equation, this one we can give equation number 3. Okay, though we can see the plate is moving with an impact of this jet with some distance, that means some kind of work done happened in this plate. So next things we can count, one more term we can calculate, the work done by the jet on the plate, work done by the jet on the plate per second, the plate per second. So why I am considering the per second means it will be easy for us to identify, because here the plate movement is given, the plate velocity is given. So work done by the plate per second is nothing but, if I, so what is the formula for work done? We know that the force which is impacted on that, okay, into force into distance. Work done is force into distance traveled. So distance traveled per second. So distance, here I can write, this is distance traveled by the plate in the direction of jet with respect to time. So per second. So this one we can write. So distance per second or distance per time is nothing but, we can write, this is velocity. Velocity, this is u. So okay, u is the velocity for the plate moving. So it is very simple for us. We can write, this is the work done equal to, finally we can write what the force equation. This is rho a, and here it is v minus u square, square bracket start, 1 plus cos theta bracket close into u. This is another one equation for the work done. Similarly, from here also we can calculate the power and efficiency. So once you calculate this work done, then power can be calculated from here by dividing the 1000 in terms of kilowatt. Similarly, efficiency also can be calculated from, like, efficiency equal to output of the jet and input from the jet. So what is the output is nothing but work done. Final work done is the output of the jet, and input will be taken as a kinetic energy which is given to the jet. So I hope you understand this derivation when the force exerted by the jet of water in the curved plate when the plate is in moving condition in the direction of jet. If you are having doubt regarding this, you can give a comment on the comment box. Thank you.